If you've not yet learnt your common ions, you must make sure that you learn all of these to be able to answer these simple formulae questions. Potassium forms a plus ion. The nitrate ion is NO3-. They simply go together as KNO3. This question's a bit mean that it doesn't tell you the valency of lead. In this particular case, lead has a valency of 2, so it's Pb2+. The chloride ion is a single minus, so it's going to be PbCl2. Lithium carbonate. Lithium has a plus charge. The carbonate ion is CO3 2-, so we're going to need 2 lithiums for every carbonate. Copper tells you it's a 2+ ion. That's what the 2 in the brackets means. The sulfate ion is also a 2- charge, so that simply goes together as CuSO4. Iron here is also 2+. Nitrate is only 1, so we're going to need 2 nitrates for every 1 ion. Now when it's 2 of the whole molecule, you need to remember to put the brackets in. Iron in this case is 3+. Again, you can see the valency written in the brackets. Chloride is a single minus, so it's going to be FeCl3. Ammonium is one of the common ions, NH4+, and the sulfate ion we've seen already. We're going to need 2 of the ammonium ions, so again, because we need 2 of them, we need to put it into brackets, and there's the formula. For the second bit, we need to be able to write balanced equations. Remember, when you're writing a balanced equation, to put the plus and the arrow in. So hydrogen is H2, copper is CuO, make sure you can write the formula first, and it's making copper and water. If we check, we've got 2 hydrogens on both sides, 1 copper and 1 oxygen, so it's already balanced. For the next one, we've got carbon plus carbon dioxide makes carbon monoxide. Carbon monoxide only has 1 oxygen. We're going to make 2 of those, as we're starting with 2 carbons and 2 oxygens. Magnesium and sulfuric acid. Sulfuric acid is one of the common formulae you need to make sure you know. It's H2SO4. It's making hydrogen, which is again H2, and magnesium sulfate, which you need to be confident writing the formula for. That is already balanced. If you check through, it's got the same number of atoms of each element on both sides. The last one is copper and chlorine, making copper chloride, which again is already balanced. You need to find out the MR of the following. So nitrogen is 14. So we've got 14 plus 4 lots of 1. That's times 2, plus a sulfur, which on the periodic table is 32.1, plus 4 lots of oxygen. If you add all of that together, you get 132.1. Remember to put all molecular masses to 1 decimal place. This one's a little bit trickier. We've got copper, which is 63.5, plus we've got sulfur, which is 32.1, and 4 oxygens. And then we want to add to that 5 times the mass of water, which is 2 hydrogens at 1 each, plus an oxygen at 16, and that gives us a total mass of 249.6. Again, remember to 1 decimal place. Okay, we want half a mole of copper atoms. Now 1 mole of copper atoms would just simply be the mass of the periodic table. So 1 mole would be equal to 63.5. If it's half a mole, it's going to be 63.5 divided by 2, which gives you 31.8. And there's our final answer. Same idea with calcium. 1 mole of calcium has a mass of 40.1. If we want 0.75 a mole, it's going to be 40.1 times 0.75, and that's going to be equal to 30.1. With this question, the first thing you need to do is to work out the MR of sodium thiosulfate. The MR to one decimal place should be 158.2. We only want half a mole, so divide that by 2, and that gives you an answer of 79.1, remembering always to put it to one decimal place. Again, with this question, the first thing you need to do is to work out the MR. The MR is 252. We only want a quarter of it, so you can either times by 0.25 or divide by 4, and that gives you your answer of 63.0. Again, remembering to one decimal place, even if that decimal place is a 0. The first thing we need to do with this question is to work out the moles of calcium cyanide. So we're going to do that by doing moles equals mass over MR. So 20 divided by 80.1 equals 0.25 of a mole. If I have 1 mole of this, it's going to make 1 mole of this. So if I start with 0.25 moles of this, I'm going to get 0.25 moles of this. So if we work out the MR of calcium carbonate, then we can work out its mass. Which works out at 25.0 grams. So we can put up here, this is equal to the moles of calcium carbonate, and that this is the moles of CaCN2. Right, for this one you need to work out how many what fraction of a mole you're starting with. So we know that 1 mole of water is 18 grams. So in 9 grams I must have half a mole. To work out how many molecules that is, I need to multiply the moles by Avogadro's number, which gives me 3.01 times 10 to the 23 molecules. For this particular question, we can actually miss a step out. We can work out the number of moles by doing the mass over the MR and then multiply that straight by Avogadro's number, which tells us how many molecules we have. That's 1.506 times 10 to the 23. But the question asks us how many atoms there are. Well, in one molecule there's going to be 3 carbon atoms and 8 hydrogen atoms. So it's going to be 11 times 1.506 times 10 to the 23, and that will tell us how many atoms there are, which is 1.66 times 10 to the 24. Right, for this one, the first thing we need to do is to work out how many moles of CO2 we have. So it's the mass divided by the MR, which gives us the number of moles. The moles of magnesium are going to be exactly the same. So you can then use Avogadro's number, but you don't have to. So this is going to be the mass times the MR. We know that the moles times the MR. So we know the moles are 2.27. The mass is 24.3, which equals 55.23 grams. We need to work out mass, and if you look at the information in the question, it does actually tell you that the density is grams divided by centimetres cubed. So if we rearrange that, we can get density, mass is equal to density times volume. So it's 1 times 0.05, which is 0.05. To work out the molecules, it's going to be the mass divided by the MR, which is going to be 18 for this, times Avogadro's number, which gives us an answer of 1.67 times 10 to the 21. Right, this is definitely the trickiest question, but it still can be worked through in the same systematic way. So the first thing we need to do is work out how many moles we have in 30 grams. So we're going to use mass over MR, which is 30 over 58.5, which gives us 0.51. It has no units, but sometimes putting mole in brackets afterwards reminds you what it is. To work out the number of particles, we're going to do the moles times Avogadro's number, which is 3.071 times 10 to the 23. We then need to work out the volume. Now we know that there's 30 grams of ionic ions in 100,000 centimetres cubed of water. So to work out how many we've got the volume of this number of ions is going to be 1 times 10 to the 20 divided by the answer to the previous section times 1,000.